So these are the ones that I will add the master mix and buffer E. Twenty microliters of buffer E. Now that we're at it, we will pipette mix.
So mix it and then you can transfer it to...
That step is really
And we have this ready?
It's ready, you just have to hit start. It's normal. I mean, you guys have done this, but you see precipitate after this step. So you precipitate. Once it warms to room temperature,
And once it warms up, it will disappear? Okay.
Yeah, I'm going to transfer these to a 1.5 ml tube because you're going to need to. Yes. I'm just going to hold this in between my fingers and warm it up a little bit. See how it's kind of clearing up already?
Yes.
Just from me warming it up. It's part of the enzyme D.
Okay.
Is it pipettable with a regular one or?
I would probably use the
wide bore.
Yeah, wide bore. You still have some debris in there. I'll just plug it right there.
I made a liquid from the stock. It's a big bottle as there are ample beads to clean up the DNA.
So that's the animal tissue material still there. Or lichen, sorry, this is a lichen.
Yes.
Not an animal.
Kind of an animal, in a way.
Okay, then timer. Wherever we have one. There. Thank you. And 5-minute incubation.
Okay, so now these need to be put on a magnet.
Okay.
And then you let it sit. What you want to do is you leave it till your solution is clear.
Okay.
and all your DNA beads are stuck to the magnet. You can kind of see them going in the back. So I don't know if you noticed, though, it's a little bit difficult to see because our sample is also brown.
Yeah.
So, but you can still see that, your DNA beads at the back.
Yeah, it was really fast.
Especially from the side. Like if you look from the side, you can kind of see it.
Yeah. Cool.
It needs to be made fresh every day so that the concentration is stable. Right? So we're making 80%.
So now this cut is without touch the beads.
Go down. Yes.
I put the timer just to know 30 seconds.
That's probably your sample, not your beads.
Yeah, but here.
I think that's your sample.
Yeah, it's too big to be the beads.
It's a tough sample. Brown too. So.
I have it.
But then this one with the magnet on the side is quite complicated. But you need a rack. Yeah, this.
Second wash.
Takes a lot of time.
I will do a spin to remove all the residual ethanol wash.
I would leave your caps open, so any excess ethanol will evaporate.
Yeah. Now I will remove it with the pizza and the residual. Now we remove. Be careful to not remove the beads or the remain ethanol.
You want this one? Is that okay? Yeah, we're doing everything on the side.
Okay, don't worry.
All right.
And we wait a few seconds that the remaining ethanol will evaporate. And then we're suspending the sugar. Okay, so this is spent again.
He wants to keep it.
They all gonna do that
possibly even the overnight step. And I think for the longer ones, like one I program
So now it's at 5 minutes.
so if they want to hear.
About part of the DNA.
And we're transferring them back to the strips now.
Yeah, I mean this one we will use just for communication. That's it.
Oh yeah.
And now just be careful to not have a hit. I was right.
Yeah, I
So,
mean, 200.
And done. Good. Now scoop it.
You're gonna have somewhere.
You can even do like a 20 microliter, right? We have them
Yeah, just to keep like the stock and dilution in case we need it. That's
more concentrated.
So I'm in the dilution.
Oh god.
Okay.
Just in case.
Yeah, but for sure we need it. I did one size, but I think we need more.
We have over there the other one.
What I'll normally do is if it's like I'll take my 2 microliters straight away sample, I'll just take my cubic if it's like too high, and I'll just take like 20 microliters out of that and to 180 of my cubic buffer, and then you don't use any more of your sample. So you just read your original cubic and
Yeah.
read it.
That's amazing that I will not use another microliter.
And then you don't use it anymore, especially if you're like cutting your particles ID to DNA, you're like not sure if you have where it's too high, you gotta glue it. It's fine if you take another 2 microliters.
Yeah, no, because I can have like
We can make maybe have 2 so we have 4 with
But yeah, so you can do that. You can always fill it from your original.
Yeah, we just think they're
I'll reuse this technique.
Okay.
Done. So now just wait.
How much are we just doing the regular 1 microliter or
Always do 2.
2 microliters?
2?
Yeah. If we have the stock and this one is the dilution. The first one is APH and the other one is CAN.
And are we using a diluted one? No,
Yeah,
we first the regular one and then
I
dilute.
would try the regular one first.
And these were the regular one.
Yeah.
Read new standards. Insert standard 1. Insert standard 2. And then one can always just check to concentration of the others, the standard 2. It's supposed to be 500 nanograms per milliliter. So very close. Close, so we know that it's reading correctly. Can first or A first?
It's okay.
APH, AHP. Read next sample. And they will do the calculate stock concentration. We have 2 microliters. This can be changed here. And nanograms per microliter, 21.7. Okay with that? Yes.
Okay, that's good.
And read an example. 19.5.
Right on.
Yes.
That's good.
Yes.
Okay, so that's not bad. So yeah, basically, and these were both 10%.
No, this is from the stock, right?
Yes.
Yeah.
But
but
10%. Actually, one was 5% and one was.
Oh, yeah.
Okay.
This was the 5%, right?
Okay.
Yeah.
So 5%.
Don't remember.
I think it was the smallest aliquot.
So we basically have about 400 nanograms and 5% and 10%. I think we stick to that pellet size because it's going to be too big per reaction. I think we do 2 of them and we can combine it.
Yeah, we have 2 of 5% already. And then this one,
There were
same.
20%.
So for this one we did 5 and 10% aliquots, and this one we did 10 and 20%. But anyway, this is like the smallest for
We
each,
get this pellet size. What I would do 2 reactions for
for
each.
each of the smallest aliquots.
Yeah. I just did this in my head, but since we have 20 nanograms per microliter, it was in 20 microliters, so we basically have about 400 nanograms total. Yeah. So we're going to start with somewhere around 800 nanograms total.
So and you were saying quite low on the input, mainly because of
The
the
pellet
nature of the
size.
sample.
Yeah. Because the pellet size is so big, you're going to add 20 microliters. You don't want that to be more than what your volume of liquid you're adding. So
So if you don't have that to deal with, you get happy to go up to 5 micrograms.
yeah. If your pellet size is small, you can
To go for it.
go for
But you need
everything.
to fit it to 20 microliters, so, right?
Yeah.
So that's the limiting.
So we didn't have maybe we went here. So when I was like aliquoting, like there was like a lot of like still pretty big pieces like relatively. They were like sediment very easily, and then the rest was in suspension. Would it be better to actually leave
Maybe some of the bigger
the
stuff.
big one at the bottom and then just be happy with what is in suspension? Yeah. Because when I'm doing a DNA isolation, I, especially with plants, like I tend to grind for a very long time, so I get the finer powder. But then I don't add liquid nitrogen so often because otherwise just it's flying everywhere. But then it's just about to go into slices anyway, so I don't worry too much. But like with I guess with high C, you have to pay more attention to that because you don't want to start tearing apart anything. So like I could have maybe gotten a finer powder on the nitrogen, but yeah, it's a trade-off.
It's tough, yeah. It should be fine.
At least you're not short of material here.
We have plenty of material, yeah. We might have to do multiple reactions, but we have plenty of material.
And they have very small genomes, I think.
Yeah.
Yeah.